way to get to homocysteine? We could keep going and end up all the way down at propionyl-CoA, and that's a short chain thing that we're going to deal with in 16. But my point is, we don't have to stop at homocysteine. You can keep breaking this stuff down, right? And we can use this for all of these different things. So don't memorize that. We're just memorizing that. I'm just showing you that you can keep going. We don't stop at homocysteine. We keep going. Okay. Is everybody feeling okay with the idea of how I want molecules drawn? Like I'll tell you specifically which parts I do and don't care about and why I do and don't care about them. Because we're going to do another one. We're only doing this. That's it. We're only doing this. We're not doing the rest of this.
What figure is this?
This is figure 1424. We are doing phenylalanine to tyrosine simply because what happens in phenylketonuria? This is phenylalanine hydroxylase. It doesn't work. And you can't convert phenylalanine to tyrosine, so you get a buildup of phenylalanine. That's why we're doing this. And I'm not going to do all the rest of that, John. We're going to do this. We're going to memorize the name of this enzyme because it's critically important. And we're going to draw this. And that's it. Look at the difference between phenylalanine and tyrosine. There's only one difference, and it is
the OH.
That's it. That changes very much how it interacts in the body because now you've got a really reactive hydroxyl group on the end versus a non-reactive, for lack of a better term, ring, right? And so, okay, so I'm going to draw this one out on the board and then I'll take a picture of the ball. So I'm going to erase this. Okay, so you are memorizing for this one exactly one change. So if you memorize the molecule and you memorize the name of the enzyme, which I know comes up in 413 or 317, all you have to do is remember which thing to put the OH group on and you're home free. And I know you memorized phenylalanine at some point in your life, far past. So, more or less, you know. Okay, my rings are always bad. I always have to count.
Do we need to know the tetrabio?
Nope, don't care about any of that. I only care about the name of the enzyme and the change between phenylalanine and tyrosine.
Okay.
Okay, I mean, you know, if you end up specializing in this field, you'll need this, but I just want this. Okay, so already, all you need to know, oh God, and let me balance my C's, right? So, and remember we're in resonance when we've got a round, so you can put the bonds anywhere, but they float around, right? You just have to have 3 every other. Like I could put it here, here, or here. I don't care about that. I just put it where the book put it. Okay, so this is phenylalanine. This ring structure is pretty non-reactive. It's super happy in this little resonance. If you're getting lost, you could write ring, and then this is your amino acid, right? CHCOO minus and NH3 plus. The only thing different is you've just added a CH2. So if you're like, oh my gosh, this is a huge molecule, I can't handle it, start over here. You just draw that amino backbone, right? That amino acid backbone, CH, NH3 plus, COO minus. And if you give me NH2 and COOH, I don't care. All right, we're in zwitterion in our body, but I know how to do that. So all you have to do is go, okay, so I've got a ring, I've got my backbone, all I need is a CH2 in between. And that's phenylalanine. Okay? Now, we need this enzyme because PKU is a big deal. Now let's change phenylalanine to tyrosine. Phenylalanine hydroxylase. That's a hydroxyl group. A hydroxylase adds a hydroxyl group. The same way, right? That, you get these other things. So all we're doing is taking phenylalanine and adding a hydroxyl group. You just have to be careful because you want to put it directly across. Oh, I want to draw it the same way that the book does it because I don't want to confuse people. So you're over here. Here we are again. CH2, CH, COO minus, and NH3 plus. This is your amino acid backbone. This is your ring. You added the OH, the hydroxyl group, to your ring. opposite the other thing, and then all you have to remember is to put that CH2 in here. If you forget to put the CH2 in here and you accidentally add this on and just this, you're still going to get most of the points because you're just missing a little part, right? The idea is that you've got the same thing and you're just adding one piece and it changes it. Okay? Are we feeling less panicked about looking at these giant molecules? Hopefully.
Can the H be next to the C or should it be?
Well, so you can write this out about, like my preference would be to write this all out like this, but it makes the molecule bigger. This is shorthand and it works well for the book and then so you don't get lost. You actually can, I don't want to confuse you, but you can write a bunch of these things like